Hey everyone, and welcome. Have you ever looked at the apps on your phone and just wondered, how did this get here? How does a simple idea turn into this thing you use every single day? Well, I can tell you it's definitely not magic. It is a process. And today, we're going to pull back the curtain and break that whole thing down.
So let's say you've got it, the big one, that billion-dollar idea for an app. But now what? Where do you even begin? It can feel super overwhelming, right? Kind of like you're staring at a totally blank canvas with no clue what the first brushstroke should be.
Well, you might be surprised to learn that the secret isn't some complex formula locked away in a Silicon Valley boardroom. Nope. The actual blueprint, the roadmap from A to Z, is so fundamental that it's being taught in high school computer science. And today, our entire explainer is coming straight from the pages of this grade 11 textbook. Let's see what it has to say. Okay, so here's our game plan. We're going to start with how an idea is even born. Then we'll look at the developer's blueprint for making it real. After that, we dive into how it's built with code, how we hunt down those pesky digital bugs, and even how some software gets a brain. And finally, we'll see why this whole process, it never really stops.
All right, first things first. Before anyone writes a single line of code, every single great piece of software starts with a problem that needs a solution. Seriously, think about it. A ride-sharing app, it solves the problem of how do I get from here to there easily? An app like Instagram solves that need to share moments with friends and make them look good. You see, without a really clear goal, an idea is just that, an idea. To make it a reality, you need a plan.
And that plan, that formal blueprint that developers use all over the world, well, it has a name. Let's get into it. And there it is, hiding in plain sight, right in the table of contents. Section 1.4, the Software Development Lifecycle, or as pretty much everyone in the industry calls it, the SDLC. This is it. This is the bedrock process for building software. So what exactly is the SDLC? You can think of it like a recipe or a set of instructions for a massive project. It's a series of clear steps that teams follow to design, develop, and test software, making sure the whole project stays on track and doesn't just, fall apart. Now, there are a bunch of different versions of the SDLC, but a real classic, and one that's even featured in this high school exam paper, is the Waterfall model. It's a perfect way to understand the basic flow. The whole idea behind the Waterfall model is that each step flows down into the next one. You can't move on until the previous step is done. First step is analysis. That's where you figure out what the app needs to do. Then comes design, the blueprint of how it's going to do it. Next, you get to the coding, the actual building. And finally, testing, where you make sure everything actually works. See? Each step pours into the next, just like a waterfall. All right, now we're at the coding phase. This is the really cool part, where all those abstract ideas and blueprints finally start becoming a real, tangible program. And this is such a great illustration of a key concept. See, developers don't write one giant, messy chunk of code. No way. They break the problem down into these small, reusable pieces called functions. It's kind of like building with Legos, right? Each function is a specific block that does one little job perfectly, and then you snap them all together to build something amazing and complex. But here's the thing. No matter how carefully you place all your Legos, the first version is never perfect. And that brings us to the next, absolutely critical phase, testing and bug hunting. So what is a bug anyway? The textbook here calls it an unanticipated error which is generally logical in nature. And that's the key. It means the computer is doing exactly what you told it to do. The problem is you accidentally told it to do the wrong thing. So how do you find these little logical mistakes? Well, developers have this super powerful tool called a debugger. What you're seeing here is how they can set a breakpoint in the code. It's basically a stop sign. The program runs up to that exact spot and then freezes, letting the developer inspect everything, line by line, to see precisely where things went haywire. Okay, so once the app is built and the major bugs are squashed, we can start adding some really powerful features. Modern software doesn't just follow instructions anymore. A lot of it can actually learn and analyze. You could say it has a brain, and that brain is powered by data. So the textbook breaks down two main ways software can learn. First, there's supervised learning. This is where you feed the program a ton of data that's already labeled, like this is a picture of a cat, this is not. It's basically learning with an answer key. Then there's unsupervised learning, where you just dump a bunch of data in and ask the program to find interesting patterns all on its own, with no help. And this isn't just theory, it's everywhere. As the textbook points out, This kind of data analysis is the engine behind weather forecasting, stock market predictions, analyzing medical records, and even detecting fraud. It's software that can genuinely think. And all of this brings us to one final, really important idea. Back in the day, the old Waterfall model made it seem like a project had a clear beginning, middle, and end. But for the apps on your phone today, the process is never, ever truly finished. So, if there's one thing to take away from all this, it's this. Building software isn't a one-and-done deal. It is a continuous, disciplined cycle of planning, building, testing, and learning from what you've built. It's a true engineering process that is always evolving.
Just think about it. Every single update you download for your apps is just one more turn of that cycle. So the next time your favorite app gets an update, take a second to look at it. Now that you know the process, you can ask yourself, what problem were they trying to solve this time? And what do you think they're building next?